Any chance you guys are seeing my screen? Good? All right. So the big idea in section 3 is understanding what like radicals are. And you'll find out that it's very familiar to something you already know how to do. And then how to multiply radicals. And it's also a skill that you are going to realize that you already know how to do it, even though it is dealing with something a little different. So like radicals are radicals that have the same index and the same radicand. So hopefully if you watched the video, you pulled that out, same index and same radicand. That's really hard to type here. And same radicand. So in order to add or subtract, we need to have like radicals. So it's a very similar concept to like terms. If you're going to add two terms together, they need to be the exact same variable. Here we have to have the exact same radicals in order to add them together. And then our second comparison would be kind of like with fractions. When we're adding fractions, they have to have like denominators. So you can't combine them until you get those denominators alike. So to combine radicals, say you have a 3 roots of x plus a 7 roots of x. If you have the exact same root, which here we have a square root, and you have the exact same radicand, which is an x in there, you can combine the coefficients. You can make 10 roots of x, excuse me. So we can combine those if they have the exact same radical part. So that's the big idea with adding and subtracting. So heading to this first example here, we're going to see that the 7BC are the exact same radicands. It's a square root again, so we have a little 2 there. So we can add the coefficients, so 14a and 5a would be 19a, and then we'd have the square root of 7bc, so we can combine those together. Looking at part B, we cannot because this radicand is different than that radicand. So you have a 3x and an x, can't add those together. So this actually would be the most simplified that you can get that one. All right, so heading into delta, let's go here. Oop. Going to head into delta math. We'll take a look at the problems that we're supposed to have. And for some reason, I don't know why it's going to this. And it's not going to work for me, is it? So we're going to take a look at how we can add and subtract because sometimes, hold on here. Sometimes it's going to not have the same radicand, but we have to make sure that we simplify our radicals. So if you're looking at your delta math, you should see that you now have your 6.3. You also have that proof of learning there, so that'll be in there as well. All right, so taking a look at this example. So here we're going to subtract, which is going to work the same way as adding. And right away, you're probably focused on those radicands. So you see you got a radicand of 150, and then you also have a radicand of 96. So you're looking at it and you're going, not the same, right? Well, let's look at it just a little bit further. If we can, we are going to try to simplify each of these roots. And to simplify, we're going to look to see, can I factor out any perfect squares? And here's where that power sheet is really helpful. So it shows all your perfect squares. So perfect squares are 1, 4, 9, 16, anything that you can square root into an integer. So 150 is going to break down into 25 times 6. 25 is a perfect square. 6 is not a perfect square, so that would be a leftover left underneath the radical. 96 is factors of 16 and 6, where 16 I can root to get 4, and then 6 would be what's left over underneath my radical. So I'm going to be able to root the perfect square out. So I root 25, that's going to multiply the 9, and that's going to make 45 roots of 6. After that, I'm going to look at my second problem. I've got a root of 16, that's the perfect square root. I can take that out. That's going to be the root of 16 is 4, which multiplies that 10, which makes 40. And that's going to then be a leftover root of 6. Now you take a look. Do I have radicands that are the same? I sure do. So basically all I'm doing now is I'm just subtracting 45 minus 40, and I will get my answer of 5 roots of 6. And then 6 is not able to break down any further, so you know you are as simplified as you can get. You can hit submit, and then it will walk through how to look at that. So you'll see their work as well. Everybody kind of does these a little differently. So your preference, if you want to follow how they're doing it, you can kind of do it either way there. So heading into another problem, if we look at problem 2, looks like I've got a 40 and then a 160. So as I look at 40, I can break 40 down into a 4 and a 10. And then 160, that's easy because that's 16 times 10. So that would be a perfect square. So I can square root my perfect squares, out. So 4, square root of 4 is 2, multiplies that 4, that becomes an 8 roots of 10. Plus, square root of 16 is 4, multiplies that 7, that becomes a 28 roots of 10. 8 plus 28 is going to be 36, so I would have 36 roots of 10, and 10 is not going to be able to simplify down any further. There's no perfect square factors in 10. So 1, 4, 9, none of those go into 10. So we should get 36 roots of 10. And there we have it. You can see the problem here, and you can see they're trying to get those like terms. So you will see when you're practicing, you have 3 of those to practice, that you'll get nice ones that will always give you those like radicals, and then you should be able to simplify those out. All right, heading back to our notes, the second idea of our notes was taking a look at multiplying radical binomials. And you're going to realize you already know how to do this because you're going to use this process. You're going to take the 1, multiply it out 2 times. Take the 2 roots of 7, multiply it out 2 times here. So what am I doing when I do that double distribution? We have a little acronym for that. What am I doing in that problem? I can see some of you saying it. Yes, we're doing the FOIL method. So that's all we're doing with binomial radicals as well. Really, your radical is kind of acting like a variable. It's kind of its own unique number. It's an irrational number. So we kind of treat it like a variable, but we're going to use FOIL. So we're going to multiply those out. So if you head to your Delta Math, your next section is going to be using FOIL. So multiplying radical binomials. So we've got a root of 6 plus 5 times a root of 6 plus 5. So you can multiply each. The one interesting thing that's happening here is when you have a root of 6 times a root of 6, if you're multiplying 2 of the exact same roots, it just equals the radicand. So square root of 6 times square root of 6 is just going to be 6. My outsides are going to be plus 5 roots of 6. My insides are going to be plus 5 roots of 6. I can't multiply the 5 with the root of 6 because they're rational compared to irrational. Can't multiply those together. And then lastly, we're going to have a plus 25. And then I can combine those middle terms. That's going to be 10. And then I can combine the 6 and the 25 to get my answer. And I should get 31 plus 10 roots of 6. And then that should submit. And then we'll get kind of a rundown of what they did. And you can see they're going to use that same terminology, FOIL. So we can FOIL out these problems as well. So you're kind of seeing some new things with these radicals, but I think you guys can agree you've kind of already practiced these skills just using kind of variables or other types of situations. We've also done FOIL with imaginary numbers and things, so it's a skill that we have been practicing. Now the last type of problem is going to be dividing. And we're going to go over just one of those problems. If I can go back here. So we have a situation where we're trying to divide by a radical. Radicals, if they're not perfect squares, are going to be irrational numbers. And irrational numbers, like pi is the most famous, is they're kind of unknown numbers because they're always changing. Like pi, I think they've got out to like maybe a couple, 3, 4, 5 million digits, but then it just keeps on going. So it's a number that's always changing. You can't divide by numbers that you don't know them. So we have to do what's called rationalizing your denominator. So we have to make this denominator, we have to make it back into a rational number. We can't have square roots down there. To do that, we are going to use a method called multiplying by the conjugate. So if I have a 1 plus the root of 3, if I multiply it by 1 minus the root of 3, that's going to get my roots to cancel out. And in my fraction, I'm going to balance my equation, multiply my numerator by the same thing. So up in my numerator, I'll distribute. So I'm going to have a 4 minus 4 roots of 3. Now down here, when I FOIL this out, I'm just going to show this process. You're going to multiply 1 times 1, which is 1. Then you're going to have a negative root of 3. Then you're going to have a positive root of 3. And then you're going to have a root of 3 times root of 3, which is minus 3 because one's positive, one's negative. But right in here is the interesting things that happens. If you have a negative root of 3 and then a positive root of 3, what's going to happen if you add a positive and negative of the exact same thing? That's going to cancel. So that's going to be gone. Then you have a 1, basically, minus 3, which gives me a negative 2. Now we're dealing with a fraction that's got a binomial in the numerator. So you can think of that as a heart. And Mr. Stoick's saying is if you have a heart, you can break it apart. You can break it into two separate fractions. So we'll have a 4 over negative 2 minus a 4 over negative 2. Right there. So 4 over negative 2, that's going to give me negative 2. And then a negative divided by a negative will give me plus 2 roots of 3. Whoops, I forgot the 2 there. Let me rewrite that. Negative 2 plus 2 roots of 3. So there would be my final result. Then I can go ahead and put that back in there. But we'll see when we get to problems, the last 4 there, excuse me, you will start to see we're going to have to use that rationalizing of the denominator. Now, this is the exact problem you have for that first problem on your assignment. So if you go back and watch this video, or if you stick around, you should be able to go into your Delta Math login, and we should get negative 2 plus 2 roots of 3. Uh-oh, I'm seeing something here. We have to hit this button here, your keyboard, hit the root of 3. So it looks like I forgot to add in the root right there. I'll go see if I can go do that. But we'll see if that is correct. Okay, and there it is. There's our solution. All right, so those problems are ones that I made. I'll go back and see if I can get that root put in there, but you can kind of play around with that keyboard as well. Well, that is all I have for you on section 3. You are ready to go to your practice. If you want to stick around and ask any further questions, we can continue to look at notes or go through any more problems. But the rest of the hour is yours for work time. Have a great day if you're heading out. If not, I'll stick around until the end of the hour. Yes.